Dave Pelton has some pretty unusual party tricks.
This is really an amazing technology, and as you can see, it's working just fine. Here's something you wouldn't normally do with a television monitor. Putting live electricity with a liquid.
But this is no ordinary liquid.
This is a material that physically looks like water. It's clear, it's liquid. It acts like water in that it moves around. And yet it is a firefighting fluid. It is not water. And we're going to show you that it's actually the vapor that puts the fire out. And as you can see, no physical liquid comes in contact with the flame, but rather the vapor from the gas being heavier than air.
At the Tyco Fire and Security Plant in Marinette, Wisconsin, they've been playing with fire since the 1940s, experimenting with different fire-suppressing chemicals. Developing new firefighting systems for different types of fire, like this fuel spill. They even test high-expansion foam to measure how quickly it can fill a space and smother flames. The water lookalike is the secret ingredient in the latest fire suppression system being built here. They call it the Sapphire system.
We're looking at protecting critical business risks. These would be rooms that may store archives or collections that you might find in libraries or museums, maybe critical business data. It's stored as a liquid in containers, and then when it's applied to the room, it travels through pipe and it'll actually mist or gasify in the room.
Chemically speaking, the magic fluid is a fluorinated ketone.
It's colorless, odorless, electrically non-conductive. And what happens is it stops the fire process by removing one of the legs of what we call the fire triangle, the heat leg. Heat, fuel, and oxygen are required for fire to be sustained. Take away any one or more legs of the fire triangle, fire goes out. We're here at one of the fire test facilities at the Technology Center in one of the heavy equipment labs. And what we want to show you today is the type of testing that we do with the approval agencies to list and certify a Sapphire fire suppression system. What we have here is a typical test firebox that would simulate a protected risk.
Inside the firebox is a mock-up of a small office.
Say a document storage room or perhaps a archive room for museums, libraries, etc. We have a system that's piped into it via a central nozzle in the ceiling. We have individual cans of fuel in the corners, and the importance for that is to be able to show that the agent has the ability to fill the volume and extinguish the fire.
The fuel cans are filled with heptane, a liquid hydrocarbon. For a room this size, they'll need to pump in about 16 pounds, 7 kilograms of the Sapphire agent.
Okay.
Its cooling properties rob the fire of heat, putting out the flames almost instantly.
And certainly while we have byproducts of the fire in the box here, that is smoke and other things, the agent itself is safe for people, property, and the environment.
Pelton says that safety factor will be a big selling point for a couple of reasons. First, no water damage. In many fires, water from conventional sprinklers and hoses can cause as much damage as the fire itself.
Imagine these being a piece of valuable art, in this case watercolor drawings. And as you can see, if we were to take the drawings and expose them to the two liquids, this one being water here, it will run and cause damage to the artwork as opposed to the material in the sapphire fluid, which will not cause damage. It has chemical properties that allow it to inhibit fire and quickly evaporate. In fact, it evaporates 25 times faster than water. So the ability and the advantage then, if you're protecting a risk, is that you will not have that damage, that associated damage that a fire sprinkler system might have.
Then there's the environmental damage to consider. A gas called halon was once the most widely used fire suppressant until its production was banned.
Halon was used for about 3 decades, and due to the fact that it is a chlorofluorocarbon, it was deemed as an ozone depleter.
This new fluid has no CFCs and it breaks down quickly.
The agent itself will persist in the environment for 5 days, as opposed to 33 years for the nearest halocarbon alternative that's out on the market.
If there is a downside, it may be the cost. You can expect to pay about $40 for every square foot of space you'll need to protect. But if you need protection from both fire and water, that may look like a pretty hot deal.